everybody. This is Advanced Dates and Times in Swift. This is 360 IDEX, and I'm Jeff Kelley. I've been building iOS apps since 2008, and we're a company called Detroit Labs. And I have written lots of date and time bugs. Show of hands, who's ever had a date and time bug? Yep, that's about right. Who's had a time zone bug? Awesome. One time, I like to tell this story in this talk. I had a client who was responsible for their own backend. And they had to write an enterprise Java, and that's fine, whatever. They were returning to us a string for the date. And they were doing that in a standard format. I think it's ISO 8601. It's the one that ends in a ZZ sometimes. And that ZZ is important. That means it's the GMT. Except this client, being in the Detroit area, everything's in Eastern time. So the string they were returning, even though it ended in ZZ, was Eastern time. So I had to write my own custom formatter to kick that ZZ out and replace it with Eastern time. I tried to explain to them that this is wrong, but it worked on their systems, so they didn't change it. So when I pitched this talk, this was the second of a two-part dates and times in Swift and advanced dates and times in Swift, and 360 just chose the second one. So to prevent everyone from starting in halfway, I'm just going to recap some of the concepts from that first talk so we're all on the same page talking about dates and times. When I say date, when I talk about the actual struct date, it's a moment in time measured in seconds since some arbitrary date. Apple platform is January 1st, 2001. These measurements of seconds are time intervals. A time interval is just a double. So number of seconds that have elapsed. A calendar, when we think about a date, you're probably thinking of something like today, August 14th. Well, that's not a date in the Swift sense. It's not a moment of a moment in time. It's not a number of seconds. August 14th is a day on the calendar. And so the calendar knows all about how to take a date and turn it into its date components. The date components are things like the month, the day, the year, the hour, the second. Calendars know about time zones. If I tell you how many seconds it's been since January 1st, 2001, and I ask you what day of the week it is, you can't answer unless you know where I am, what calendar I'm using, that kind of thing. So this is all the components that you can split a date into using a calendar. Really useful stuff in there, all the way down to nanosecond. And the question I really asked in this first talk is, why are dates and times so hard? This is something that from childhood we all learn. We learn how to tell time. We learn what a calendar is. I've got two kids, 2 and 5, and right now we have a little Disney-branded magnetic calendar. And every day we change the date, we say what month, day, and year it is, we say what the weather's like, and they're learning at a very young age how dates and times work. So why is it so hard to develop? Well, the answer is calendrical fallacies. So this is your calendricalfallacyis.com, made by Dave DeLong, who works at Apple. And there are a lot of things that we assume that just aren't true with calendars. Like for instance, the day is so many seconds long, the day is so many hours long. So I'm going to pull some examples, some really fun examples from that first talk. This is the state of Indiana. You may notice that unlike other cities, there are 3 levels here in the time zone definition for all the different areas. Every different color in Indiana represents a different time zone. So imagine you're writing an app that is for physical stores, and you have an app in the yellow store in the yellow zone, and your user is in a different time zone, and there are other stores in other time zones. And the user is looking at a list of local stores, and you want to tell them which stores are open and which stores are closed. And all you have to go on from the server is a string that says 9 a.m. to 9 p.m. You're going to have to do some work to figure out what time zone they're in. Some of the trickiest code that I've written along this line was coupons for a client. This is a food store chain that has coupons, and these coupons are only valid in certain stores at different times of the day. That that coupon validity depends on the time zone of the store. So that's really fun. In fact, one time I was in Indianapolis watching a friend run a marathon, and we stumbled upon this protest about how many time zones. So there are so many time zones in Indiana, they protest for things. Now, if you think Indiana is bad, this is a map of Antarctica. I don't know if you can read it back. Time zones go from UTC -4 all the way to UTC +13. So I think it has to do with which country got there first. I'm not really sure how it all works. I'm sure this is a lot of fun for people who are in Antarctica. Now imagine you're writing an app. It's a photo app. It's a way to organize photos from a trip. And someone's going on this Antarctic excursion, and they're bringing their camera, and their camera doesn't have good time zone support, but it does have GPS. So through the course of the day, they're going all around taking photos. And then you're trying to display the time the photo was taken at the local time of the time zone. That is just one of the things that can happen. Okay, that's simple enough. Let's talk about Easter. Now, Easter, as we all know, falls on the first Sunday after the full moon following the March equinox. That's the Paschal full moon. It's pretty easy. So to figure it out, there's this algorithm called Computus, and using like math markup, if Xcode doesn't really support having variable height tables here, rest assured, there's this huge algorithm for figuring out the month and day for Easter in a given year. So I translated that to Swift, a little bit easier to read. Just make a bunch of constants and figure it out. What you have as your input is an integer for the year. Sure enough, if you run this for 2017, it'll give you back date components with a month and day of April 16th. Don't check, I'm sure it's right. So those are just some quick examples of date and time code that can be tricky. The things to remember, takeaways from the first talk, are that dates are moments and times. So if you want to compare two dates as to see which one happened first, use the date. It's just a double, very easy to compare. Calendars know about the way we talk about time, the month, the year, the day. And calendars are useful for converting to and from those things, and we're going to use date formatters to go from a date to something that the user can read. And date formatters are great because they're localized for free. You don't have to write that code yourself. So, for the advanced date and time portion of the talk, we're going to try to solve some common problems that you might have in your own code, trying to reason about dates and times. We're going to start with date intervals. So this is a date interval I'm creating here for the time period of this talk, assuming I go all the way to the end. Making two sets of date components. Both have a time zone defined as America/Denver. They have a year, a month, a day, hour, minute, and second. And then we're going to have the calendar create dates from that information. So using that information we've given about the moment in time, it's going to create it for us. And then with those two dates, we can create at the bottom a date interval, which represents that interval between the two. A date interval is kind of a new struct in Swift. It came iOS 9. Lets you do things like get the duration. This is 2,700 seconds long. You do the description. And note that description is in UTC because the date interval is created with two dates. The date does not know about time zones. The date is a moment in time. And so when the debugger goes to print the description, it doesn't have a time zone to work with. It's just going to default to UTC. And then I can ask that date interval if it contains the current date. And because I'm talking right now, that's true. Now, if you want to format that, you can use the date interval formatter. And here we have a nice human-readable string for the time that I'm giving this talk. And so that's one of the things that used to be pretty hard in iOS, getting this formatting to work right. Because a date interval formatter will automatically take into account when that date describes multiple dates and give you the right string to show your users. We can make it a little more complicated. So this code, I want to have relative dates. I want to be able to say today, this time to this time. So I can use some also relatively new methods on the calendar. Is date in today? Is date in yesterday? Is date in tomorrow? Again, these are some convenience features that have been recently added for common problems that you have. The calendar knows about time zones, so it's automatically going to know for the current user, current time zone they're in, is that today, yesterday, or tomorrow? If it is, great. We'll store that in a prefix. And then if not, we'll set the date style of the formatter to short so that it'll just show the date. So for today, it'll say today, tomorrow, it'll say tomorrow, and the next day, it'll fall back to what we saw before of month/day/year. These formatters are also, because they're localized, you don't have to worry yourself about localizing an app for the UK and switching month and day when you format it. So that's the first thing, data intervals. Next thing, converting between these data components. You might ask yourself, how many days are there in this month? So you can use this method range of in for. So give me the range of this unit in this larger unit for this date. So in this month, for this date, there are 31 days. In this year, there are 365 days. And if you ran this with a date that was contained in a leap year, of course there'd be one more. So the question we're going to answer now, which I'm sure many people have had to compute in their own apps, is how many seconds are in a year? I can use maximum range of seconds on the calendar to know that on this calendar, no matter what, the range of a second goes from 0 to 60. And you can also use that for minimum ranges for days. So on this calendar, every month has at least 28 days. But if I use that range of in for method for seconds in years, I get back 0 to 60, or 1 to 60, because there is no 61st second. Leap seconds notwithstanding, you can't make a value of seconds that goes that high. So, if you need to figure out how many seconds are in a year, we've got some calculating to do. So, first draft, we're going to go through, okay, how many months are in the year? Great, let's go right through those months. Let's figure out how many days are in that month. Great, okay. Let's go through those days, and because, time or daily saving time is a thing, it might not be 24 hours. Let's figure out how many hours are in that day. And then for each of those hours, so on and so forth. And this is getting out of hand. So I'm going to switch to Xcode, and we're going to try to answer that question. How many seconds are in a year? We're going to make a new playground. All right, so I'm just going to make a quick blank macOS playground. Call it dates. Get my cheat sheet up here on the iPad. So, we're going to start with a year. Is that text size good for everyone in the back? Everyone read that? Okay. With this year, I'm going to make some date components that I can reuse. So, the date components I'm going to supply are going to be month, day, hour, minute, second, nanosecond. So 1, day is 1. It's always going to be January 1st at midnight. And 0 nanoseconds, because I can. So I have these date components. These are pieces of calendar date. And I'm going to copy them to the beginning of this year. Now that you have this copied, set the year to that year constant I made above. So now we have beginning of this year components for the beginning of this year. All right, so with that, I can get a date from our calendar. I'm going to make a calendar constant up here real quick. We're going to use that calendar event. Okay, so I'm making a date from the beginning of this year. I'm going to go ahead and force unwrap that because I know that's going to work. That gives us January 1st, 2017 at midnight. Cool. So now I'm going to do the same thing for the beginning of next year. Actually, not going to do the same thing. So I can ask the calendar for the next date after a date matching specific components. So we're going to go after beginning of this year, matching beginning of any year components. And for the matching policy, we're going to say strict. And that gives us January 1st, 2018. We're going to come back to this concept a little later, but that gives us that date for the beginning of next year. I could have also just copied those components again and had the year be 2018. So now, back to our original question, how many seconds are in this year? There's a few ways I can do that. I can just go to the beginning of next year and say the time interval since the beginning of this year. Xcode runs it, I get 31,536,000. Of course, that's right. That's one way I can do it. I can also use a date interval. Let's see, starting with the beginning of this year, ending beginning of next year. And then I can ask that interval for its duration. We get the same value. And finally, there's another thing we can do. I can ask the calendar and say, give me components from one date to the next. And that component is a set of components. I'm going to ask for seconds from the beginning of this year to the beginning of next year. And that gives me a date components object, construct in Swift, ask for its second value, and we get the same. Now what I like about this last approach is that this can handle multiple components you can ask for. I can ask for seconds and minutes. And that gives me a date components with 525,600 minutes, as we all know from the song, and 0 seconds. So because I've passed in minutes as well as seconds, it's only going to give me the seconds that are remaining after minutes. So predictably, if I come in here and I add month to that set, now we're going to get 12 months, 0 minutes, 0 seconds, which is what we expect for 1 year. So in this way, you can measure any component from 2 dates. So instead of doing that math yourself, instead of subtracting and trying to figure out how many days that is, it's all built into the calendar. So next time you have to count the number of seconds in a year, that's how you should do it. Any questions while I have a playground open? Great, okay. So that range of in-for method, that's really only telling you the bounds possible for that unit. But this is still pretty useful. If you're making your own date picker, this is how you would populate it. If you're making your own calendar view, this is how you would create it. And doing it this way would prevent you from having the wrong number of months and days in your calendar. There are calendars that aren't the Gregorian calendar where these these values differ. There are calendars with months that have very few days in them. If you look at, I think it's 1752, when the Julian calendar changed to Gregorian, September is missing half the month because they changed it. So you can never assume anything. But you don't always want to use it. Like we saw with coming second. Also, I had this debate at work with a coworker who was trying to populate a credit card date or expiration date picker. And he's trying to go through using all these methods, trying to do it the right way, but really that's not the right way for credit cards. Credit cards, they're not going to change. The credit card processor you're using isn't tomorrow going to support a new 13th month that somebody voted in. The actual domain you're solving here is valid credit card expirations. So just hard code it. All right. Raise your hand again if you've ever had an alarm fail to go off around the daylight saving time transition. Yep. This has happened multiple times to Apple. It seems like, on first principles, the kind of thing you should only have a problem with one time. Like, oh, we had a problem, now we fixed daylight saving time. And that's not how it works. I have a microwave, right? It's my old microwave now, I got rid of it. My old microwave at home, it was sophisticated. It had a computer. And it automatically set the clock for daylight saving time. So it was great. You just put in the date and the time, and when that transition period rolls along, perfect. Except, in between that microwave being manufactured, me buying my house, we changed the law. We moved up daylight saving time 4 weeks. So that meant that I had to go in on the real transition, change the time. Then on the old transition, I had to change the time again. Then on the old second transition, I had to change the time. And then on the real second transition, I had to change the time. So this computer had saved me from changing the time twice a year by making me change it 4 times a year. So you might have a notification you want to give to your user at a specific time, like when they set their alarm to go off, or when they usually go for a run. Now remember, earlier we used this beginning of any year components. I want to join the Wi-Fi. We used this kind of like search, right? We're looking for the next date after that date, and you can give the matching policy. Quick aside, this matching policy of next time is very important. In Brazil, when they change daylight saving time, there's no midnight. They skip midnight. So if you try to pick a date at midnight, it's going to return nil, which you don't think can happen from a calendar, but it can. So this next time policy returns the next valid time after that match happens. I still don't want to join the Wi-Fi. So let me turn my Wi-Fi off real quick. So the new user notifications framework has this concept of a trigger, the thing that happens to make your notification appear. And you can use the date matching repeats initializer to pass in those components that match what you want. So if you want it to happen every Wednesday at 9:30 a.m., great. Make some date components, give it the day of the week, give it the time, pass it in. And then you can verify that with the next trigger date on the notification. So here's going to fire January 1st, 2018 at 12 a.m. If your users or jet setters have been always flying around the world, you don't have to code the thing that happens when they change time zones. The system will take care of it for you. So whatever time zone they are in, they will get this notification that says Happy New Year. So you tell the notification center to add this request that has content and has a trigger, and there you go. So this is a really common problem people have had in the past in the new user notifications framework. Makes it very easy using those data components like a filter. Now you can have that happen. All right, so that's all I have for slides. We're going to go to a demo app. This demo app is called Drop It Like It's Clock, and it's really cool. Okay. So I'm just going to run just going to run this app so I can show you what it does before we talk about how it works. Okay. So this app starts with a map. Oh, but I kind of need the network now, don't I? It just works. There we go. Okay, let's rerun this. So we start out with map view. That should hopefully, if the demo Wi-Fi gods smile upon me, we'll start to load a map. And what it's going to do with the long press on the map, it's going to add an annotation to the map. Here we go. So we are here in Denver. Inside in Denver. Simply there's not happy with me right now. Guess we're going to be in Texas. All right, if I long press, we get this clock. So here in Texas, and that is the local time. In Texas, this clock is going to update automatically, hours, minutes, and seconds. I'm going to come over here. I'm just going to blame Xcode 9 beta 5 on why this is going so slow. I'm going to go over here to Utah and drop a clock. Maybe. Well, you get the idea. So you drop the thing, clock happens. Demo's not going to work right now. That's fine. Because really what I want to talk about is how this works. So I have this map view controller. And when I handle long press, there's no API in Cocoa or Foundation to get the time zone from a geolocation. It's kind of a surprising omission. Google has their back. The Google Maps API will happily give you that information. So I'm going to get that time zone ID from the JSON in the response. And the time zone ID is going to be something like America/Detroit or whatever. I'm going to make a time zone with that identifier. And then I make a clock annotation with that coordinate and that time zone. I'm going to add that to the map. Now, the clock annotation, it's very simple. Just contains that coordinate and time zone. But in that view controller, the delegate method view for annotation is map view. If it is a clock annotation, I make a clock annotation view. And that's where the magic happens. So our clock annotation view takes in its annotation. We make sure that's a clock annotation. When we crash, it makes the clock view. We get our white background color, gives all the stuff it needs to know. And then when the clock view, this is the view for that annotation. It's a clock view. And it has this display link. And display link, has anybody here ever written code with an NS timer that has like a 1 second tick for updating a UI? Yeah, and it might work for a number of seconds, but for a clock, we want the animation to be smooth. CA display link is going to call us back using a method that we give it every single time the display refreshes. So we don't need to worry about having any kind of fancy animation. We're just going to redraw this clock every time the display refreshes. And then there's all kinds of stuff for drawing the actual clock. And to debug this, to test it, instead of trying to run it on the map view, because you saw how sometimes it doesn't go so well. You have this map view, and maybe it's going to load, maybe it won't. Got network dependencies instead. I have this clock UI in a framework called clock UI. I have a playground in my project where I can just quickly make adjustments and rerun in this playground and spit out a clock view. So I'll post this code on GitHub, but that's a great way to just kind of prototype this UI for drawing the clock. So now that we have all this running, I have this new iPad Pro here. And this iPad Pro has a refresh rate of 120 hertz. So I want to make sure that it's going at the full 120 hertz. Can anybody tell me, does anybody know how many milliseconds you have to draw a single frame at 120 hertz? 8.3. So if you think about it, for this display, it has to refresh every single pixel every 8.3 milliseconds. If you've ever done any 3D programming, you know that's very tough. So I'm going to uncomment this. And we're just going to see, every time we draw the current watch face, that's what happens when the display link calls us back. It's just going to log out the interval since the last update. Oh, I just updated my iPad to beta 6, so you can sit here while I'm copying symbols. Was anybody in my watch workshop yesterday? Okay, you're gonna hear a joke twice. So the other day I was at the DMV, and those little paper tickets they give you to signify your place in line. I lost it. I don't know. I think it fell between the seats. I don't know. So I went up to the front desk and said, "Hey, I lost my ticket." And man, they tore me a new one. Yeah. So we'll see how long this takes. I think I can go in here and yep, it's preparing for development. Anybody who does watch stuff knows that processing symbols is a lifestyle. So every time you update, you've got to process symbols for the phone and for the watch, and it's per watch model, so if you have 2 watches, it's twice as bad. But what you'll see here is that this callback is happening at 120 hertz, and every 8.3 seconds, or 8.3 milliseconds, it's coming in and updating this watch. So the whole point of that is to say that if your UI has anything time-related that needs to update, you're going to want to use CA display link. That's going to save you the effort of trying to figure out when you should update your UI. So if you have a clock, if you have a progress bar in media, like a podcast app, if you have anything that changes, just use CA display link. And as long as you can get your work done in 8.3 milliseconds, you're good. Any date and time questions while we wait for my iPad's symbols to be processed by my Mac? Yes. Yes. So I think is it in the attendee Slack? Is that what we're supposed to? Okay. I will figure out a separate slide. I will post a slide. Cool. So I'll put this there. I'll put the code there and slides. Yeah. Yep. That's the plan. Yep. No, that's the only joke I know. That's the one. I had this reputation at work for like making a lot of puns, but the thing is, like I'm not in control of it. It's like there's a background process running in my mind that scans all incoming text for puns, and I just say them whether they're good or not. But I don't control that process, so I can't make a pun on demand. So I would not be good at those pun competitions. Those are things, by the way. They are fun competitions. All right, well, that's all I have. If you care, we can all stick around and watch this spinner spin. I think you get the idea that the numbers are going to go up by about 8 every time, so I'll spare you waiting. That's advanced dates and times in Swift. It's a never-ending topic of complexity. Hey, So if you have any more questions, let me know. We are about to run on the iPad. Okay, it launched on the iPad. There's a suspicious 2 connections to my personal hotspot. I'm just going to ignore that for now. So we see this thing is updating a lot. So you see it quickly, but take care that the thing that you do in CA display link callbacks is very short. Is like what I'm doing is just changing the transform on some views. You especially never, ever, ever, ever want to create a date formatter inside of that type loop. Those are expensive to create. The documentation goes out of its way to describe how expensive they are to create, and you will not have a smooth UI after that. Yes?
You're saying like if a user is a global traveler, in order for it to magically work, they have to have access to the GPS. Like not saying it's not going to magically follow the GPS.
So that's what I thought. I thought the question was, for this to work, the user has to be able to reach NTP servers to set the time. I was on a plane. I was over the ocean, and there was no Wi-Fi. This was an old plane, and somehow my phone changed time zones. And I don't know this for sure. I think what happened was either it got GPS or something, and it knew enough to do the time zone on its own. I cannot verify that's how it worked. All I know is I'm in the middle of the Atlantic, and my time zone changed. There's no Wi-Fi. Imagine. Yeah, the question is about performance of all these calendar methods, like all the ranges. But yeah, so it should be performant enough that like at a one-time thing, you're going to create that, you quickly figure out what it's supposed to be. So you're iterating over like a year's worth of events.
Yeah, years worth of events at some times. Depends on how the designers know exactly from should.
Yeah, so that's the trade-off, right? You want to trade-off between having the total complete, correct calendar code and actually getting it to work. So without looking at specifics, I would just say tweak it as best you can and try to cache as many of those as well.
Do you have any advice on what high performance
So data formatters, creating those are definitely a performance hit. That's the thing where like apparently also looking at calendar. Yes.
this is hopefully a question for anybody that comes to know, but in that case, would like the new coordinate archery index, like you store those dates with archery, so it can index on range. They say it's good for location data, but I don't know if
I don't know, I've never used coordinated as archery, so
it's not as far as range.
that's why I haven't used it.
Like in open source libraries.
So there are a few open source data libraries. Format Kit was really good for Hotnet for Apple updating it. I don't tend to use a whole ton of them, just because I don't usually have the Formatter Kit has some edge cases in it that Apple's code doesn't supply. 5 minutes, I want to go to the question. So I looked last time there was leap seconds, and the phone UI does not go. So what's supposed to happen is supposed to go from 59 minutes and 59 seconds to 59 minutes and 60 seconds. Just every now and then, they decide, I don't know who they is, but they decide that they can have an extra second per day. So if they heads up in 6 months, there's going to be an extra second at the end of this day. That's called leap seconds because the Earth's rotation is slowing down. So there are a few different approaches different companies take to it. Some companies add on a 60th second per minute. approval on their servers, they smooth that time out over the 60 seconds of that minute. So each second is just a tiny bit longer than it should be. There are different approaches. Like we saw, the range of a second, the maximum range in the calendar, does not include 60. So you will never get a 60 or 51st second in iOS code. So the question is, how do you deal with anger when someone doesn't send you time? In this case, it was really difficult because I was actually at the client site, like talking to the person and trying to explain this what this CZ meant, and it just wasn't getting through. And I think the answer for Dave DeLong was to make your political fallacy is.com. So you can just get it out there. Yeah. Oh, yeah, that's a great one too. AnnotateFormatter.com will let you preview what your date formatter string is going to look like. There's one more question right there. It's going to be the last one. Yes. Yeah, I thought that format is pretty widely used, especially for Xcode. The question was serializing things like recurring events. As soon as you hit the limit of what iCal can do, you're going to have a problem. So one of the toy apps I made was for creating events relative to other holidays, and I included Easter as a holiday. iCal format doesn't support that, right? So that's going to depend on what features you support. iCal is a great starting point for serialization, then you can export to other apps. And related to that comment you made about the ISO format, so this library, all the stuff that I was using is based on, I can't remember the name, it's a C++ open source library that handles all of this. So many platforms are built in the same underlying technology. This is Apple's like wrapper around it for Swift, which is based on the wrapper around it for Objective-C. And I was using, so right now I'm doing a web project, and I was using Moment.js. And that made me realize just how good Apple's libraries are. In Moment, everything is 0 indexed. So January is the month of 0. That's fine. You can deal with that, except day is 1 indexed. I don't know why. I had to find it out the hard way. So that is our time. Dates and times are a very difficult topic, very hard to get right. Hopefully, some of this saves you some heartache in the future. But hit me up on the 360 Slack or Twitter if you have any more questions, and I'll be sure to post all the materials. Thanks for coming.